Hey everybody, this is part 7 of my 8-part series on how to fly radio control airplanes, and this is fixed wing. This episode we are going to talk about multi-engine airplanes. And what I'm going to do though is I want to make some definitions first. To me, a multi-engine airplane could be 2, 3, 4, up to 6 engines. Okay, but I'm going to talk about twins a lot, which means just 2 engines. Because for model aircraft, a 4-engine airplane that loses 1 engine, it really isn't going to care that much. You're going to have some rudder in there and you can fly it. A twin-engine model airplane that loses an engine has to land. Most of them can't feather the prop. I don't know any that can feather the prop, so you're just going to have to land. Okay? A 3-engine airplane normally will have an engine on the vertical stabilizer, or they'll have 3. Losing engine on one of those, like a Trilander, you can probably still fly it, but you need to be very quick on the controls and know how to fly rudder. But the way I want to start this is talking about full scale first. Okay? So a lot of people think twin engine airplanes were created because that second engine is there for safety. And that's nowhere near the truth. The FAA forces twin engine airplanes to be able to fly successfully on 1 engine. The reason there's 2 engines there is so they can go fast. You could put more horsepower on an airframe. Jumbo jets, if they could have 1 big honking jet engine and it would fly the airplane as fast as they wanted to go, they would do it. But they have to put 2 on there. But because of the amount of people they put on it, it still has to fly very good on 1 engine. So I just want everybody to understand the 2 engines on an airplane isn't there for safety, it's for performance. And most of the time, it creates more danger on full-scale airplanes and models. So let's dive into this. Okay, most pilots and insurance companies know that twin-engine airplanes are more dangerous than a single-engine airplane. Try to get insurance on a twin if you're a low-time pilot. It's enormous. The level of training and skill you need to fly a twin-engine airplane is enormous. Okay, keep in mind, you practice basically your landings and takeoffs every time you land and take off. Okay, you hardly ever practice single engine out. Okay, you know, I've got a lot of time in twins. Now, I'm not signed off or have my endorsement for twins, but I have friends that had twins, and we had a lot of fun in a Seneca and a Seminole Piper product. If you take that up to 4,000 feet at gross weight, and you pull an engine back and feather it, it is really hard to get more than 200 feet per minute, 250 feet more per minute out of the climb on that airplane, where you're usually used to 600 to 750 feet per minute. So that airplane will fly on 1 engine, but at gross weight, that would be really hairy if you were taking off like a Piper Seneca, you know, just got it airborne at, let's say, 68 knots, 70 knots, 75, lost an engine. You know, you got to be in the blue line, and I'm not going to get into that, but on full-scale airplanes, there's a certain airspeed band you have to be in for the rudder to be able to be effective. Okay? 4 engines are always better than 1 engine or 2 engines. Because you lose 1 of the 4, you're still going to fly. If you got 6, you could lose 1 engine and not even know it. But if you got a twin and you lose an engine, you better be a kick-ass pilot. So a single-engine airplane is safer than a twin-engine airplane. You can hear and feel what's going on in a twin when you're flying it. You know, if 1 engine starts to act up or do anything really weird at all, you feel it yaw. I was in I think it's a Piper 421. And there's a boost pump or something that the pilot I was flying on had left the boost pump on. And when we took off, the engine went really, really super rich. I mean, we were only about 100 feet in the air. And we felt the plane yaw before we really knew what was going on. And he looked down and he saw that, you know, he had manifold pressure, you know, normal on 1 engine, and it was a little bit low on the other engine. And, you know, the first thing we did was went through the checklist, and he realized that he still had a boost pump on that was supposed to be off. I think it was on or off, but the engine wasn't close to dying. It just turned really, really rich from what I'm remembering. We could feel that instantly. So the thing about full-scale airplanes is you feel everything. And you can feather the prop in a full-scale airplane. Okay, when you pull that engine back to idle in like a Piper Seneca or Seminole, you'll feel the plane yaw a whole bunch. But when you feather it, you feel it kind of unyaw a little bit. So now let's talk about models. They're very cool to have. They got that wow factor. They're awesome for ego. When you have a P-38 or a Marauder, you know, you are Hollywood, man. You're the guy with the big white clock around your neck, and you're in the money, man. You're just tossing it everywhere at the field because you got a twin. The reality of it is you better be an unbelievable good pilot, be flying twins. Okay? Twins are more complicated when you think you got 2 engines, you've got 2 ignition systems, 2 fuel systems, 2 systems for fueling and defueling. You just got all kinds of more complexity the moment you go to a twin engine airplane. You only hear what's going on with that airplane and see it. You can't feel it. You can't feather the prop. So and you can look this up, but a prop that is windmilling with no power has more drag than an engine that has stalled. I mean, the propeller is stalled. It's not spinning. It stopped spinning. So on a model airplane, at least the engine stops spinning and you got a little less drag than if it was windmilling. Okay, on some electrics, it will keep windmilling, which is even worse. But if you sized your electric motor right, your ESC and your battery right, and your prop right, the chance of you having an engine failure in a twin engine electric is almost 0. Now let's just say you've decided I'm going to enter the world of twin engine airplanes. Okay? And there's some things you need to make sure happens. Like I said, if you got electric, chances are both these motors are going to run perfect. If you've got gas and you can get them to idle right, run through the mid-range right, and run at full throttle, being just on the tad rich side, because you never want the engine to die, you're probably going to be okay. If these are glow engines, this airframe will have an expiration date. So out of 100 flights, you're probably going to have 20 dead sticks, or you're only going to have 20 flights before you crash the plane. Glow engines, to me, are just so unreliable. Now, there's a couple of glow planes that were made back in the 80s and 90s that would fly okay when the engine was out, but you need to be up and moving, going fast to have air over the rudder. Okay? So, but let's say at the end of the day, you've gone through all of this and you say, I still want to build a multi-engine airplane. There's a couple of things that you need to think about the way multi-engine airplanes for models can work. You can buy what is like a synchronizer. So if one engine drops the RPM, the other one drops with it, and you just dead stick it. I don't know much about it. I'm not going to go into it, but I know a couple of guys that have had those on their airplanes and they love it. Now, it scares the crap out of them because it's almost like you're flying a twin engine airplane, which in your head, I got 2 engines. But when one dies, it pulls the other one to idle, which is what you should do. One of the things that people don't realize with radio controlled twins is how much rudder is truly needed. Okay? I saw a twin engine airplane take off one time. The engine died and the plane just started to auger over. I could see he had opposite rudder. And I'm just thinking, oh man, give it full rudder, and it crashed. Well, when I talked to him, he only had 15 degrees of rudder travel. Well, that's nowhere near enough if you've got an engine failure. So I always like to look at the maximum you can get a rudder to move on a twin, and I always set mine at 35 degrees. Now, some airplanes you can go more, but there's a certain point that you can actually get an aerodynamic stall in the rudder. The rudder turns too much and it's just becoming a brake back there and it's not giving you any of your yaw control. So that's very, very important to think about. You need to be a hell of a rudder pilot if you're going to fly twins. Okay? You just need to be. And always, every moment you're flying, know that you could have an engine failure. Always be ready to chop the power and dead stick it back. Treat it like it's a single engine airplane. The moment you hear anything going on, treat it like it's a single engine airplane. Now, if you're taking off and you're flying right away from you and you've got enough time to get a lot of rudder into it and get the nose down, basically, the moment you hear something going wrong, just level the plane. Do not climb. Because if you can go down the runway in one engine, have enough rudder, and then pull the nose up and keep it flying, you might be able to get it back. Normally, I'll just cut the power and land straight ahead. That's one reason I always like to have it use all the available runway for a multi-engine airplane. If that engine dies, if you have 500 yards and your engine dies 100 yards into your takeoff, you've got enough room to land. But if you're taking off with 200 yards left of the 500 yards and lose an engine, you might hit the fence or crash the airplane. What do I need to know when I'm building the airplane? I had a couple of twins that I scratch built back in the 90s, and each of them I put 3 degrees of out thrust, I guess is what you'd call it. The reason I did that is if this engine died, this engine's always wanting to pull me this way, which is actually helping the amount of rudder I need to keep the plane flying straight. Make sure you build your plane light. Twins that are light survive. Heavy, high wing load twins, the moment you lose an engine, it's all over. That motor that's at full power or whatever is going to auger you over unless you're lightning quick and chopping the power. Keep in mind, there's kind of a psychological thing that goes on in your mind when you lose an engine on a twin. And I had a lot of glow twins back in the day. You take off with a twin and you're like, in the back of your mind, I got a twin engine airplane. One engine dies, I still have one that's running. There's just something in our system, the way our brain works, that we still think having two engines were okay. And what always happens is when you lose an engine, the first thing you want to do is put the nose down and add a bunch of rudder and see if you can fly it. And that's actually not the safest thing to do. The safest thing to do is chop the power to idle and start to glide back around. And if you want to try to add a little bit of power to get you back, you can try it. But even myself, when I lose an engine, my first instance is kick in all the rudder I can, put the nose down, see if I can fly it. And it's not the smartest thing to do, but for some reason, our psyche thinks we can fly the airplane. Like I said, build a light airplane. If you got a light twin and you lose the engine and you pull the engine back to idle, you can glide back down. It's not a high wing load. Don't overpower the plane. Now, if you're building a pond racer or a P-38 that you're wanting to just go really fast with, have at it. Put as much power as you can. But keep in mind, that airplane is pulling a lot of acceleration on both motors, pulling at full power. When one dies and it can't be feathered, I mean, it's just an instant kaboom. It's just wanting to pull your airplane. I wiped a P-38 out completely doing that one time. And it was probably one of my most spectacular crashes because the balsa was like 40 yards long. I mean, it was just get the trash can, pick up a couple of motors, throw everything else in the bin and burn it. But I hope you find this informative, everybody. Look, I am trying to talk you out of doing twins, okay? I don't believe half the RC pilots I see fly know how to use the rudder, okay? I only think 10% of us that fly truly can land on a same spot like 5 times when you fly. When I used to skydive, they had a thing called a pro license, and I'm sure it's still out there, and it's where the skydiver had to call. He was going to land on a target 10 times in a row, and if he missed it out of those 10 times in a row, he had to start all over. Flying model airplanes, if you try to say to your friends, throw 2 paper plates out there and land in between those paper plates within 20 feet every time, I wonder how many could actually do it. And I'm talking about with warbirds and scale airplanes. I'm not talking a little light floater plane. I'm talking about if you're flying a scale Cherokee or you're flying a P-51 or whatever, can you land in between those paper plates within a 25-foot area each time? But let's say you really do want to get into a twin, then please get online and look at all the flight training for twin engine full-scale airplanes. They'll talk about so many things that put in the back of your mind what's going on with your model. I think multi-engine is cool. That's one reason I love to build them. But just about everything I build has at least 4 motors or more. I hate twins. I had an Islander, a twin engine cargo plane that would fly in the Caribbean, and I made it a trilander, which means I put one of the engines on the vertical stabilizer because I hated it as a twin. And as a 3-engine airplane, it was awesome. So I hope you find this informative, everybody. And I know I'll probably get some pushback on this one because there's an awful lot of opinions on flying twins. But like I said, if you're electric, you're probably going to have absolute 100% success. And if you're a novice wanting to get into twins, I would fly electric because your engine's not going to die. Gas, if you know what you're doing with gas engines, they can be virtually 100% reliable. If you are flying glow, good luck. Now, I don't include 4-stroke in there because if you know how to dial in a 4-stroke glow engine, you probably could have a successful twin that would never lose an engine. But thanks for watching my videos, everybody. I'm hoping to have the video 8 done in the next couple of days, and I was kind of keeping that secret, but part 8 of this video series is basically going to be from the moment you decide you want to fly a model airplane all the way up to mastering being an exceptional pilot. And I'm going to go through all the steps that I've done with training people and teaching people. I'm going to go through all the things I've learned the hard way. And I'm going to go through some things that today makes it so much different than it did 30 years ago. Just absolutely different. So thanks for watching my videos, everybody, and I'll see you next time. Have an awesome day.